So let's see. I'm going to start off with a kind of like differentiation slide deck between noSQL and SQL. Some of this might not make sense, but don't worry about understanding noSQL because we're working with SQL, but I just wanted to give you guys like, a visual example of what the difference is. So they are incredibly similar as far as the management systems go, noSQL and SQL. Data storage techniques are identical, except noSQL databases use an ID index to achieve O of 1 complexity, whereas SQL databases use array-like techniques to achieve O of 1 complexity. And so this is what a noSQL database would look like, essentially, where we're assigning these hashed integer values to these objects, so that way we know exactly where each person is, and then we would query essentially the ID associated with the user, and that would get us to where we're exactly looking for. Again, this isn't like super important right now. Obviously, looking at an SQL database, it's extremely clean, easy to understand exactly what's going on. We have all of our column titles at the top. We have all of our foreign keys on the side, and then all the information that we're looking for. So they are similar, but SQL is faster at computing relationships because it can skip ID indexing steps by just going to the index that it's looking for. As we said, it's going to be accessing the data in an array-like method. So it's going to be accessing the data like an array. So it's going to help a lot with making our code more efficient and being able to access and mutate data how we see fit. And then it's stored in a binary format because it's SQL, not JSON, whereas noSQL would be more akin to something like JSON. And so, yeah, the problem with noSQL is we have to first parse the object once we get there to find the specific key that we're looking for. So once we pass in like 410 and we get this user, then we would have to say we're looking for text and then give me the value of text. Whereas with SQL, you could just simply say, get this user at this ID. And it just goes like an array index. It's like, I know for a fact that 412 is exactly what this guy's looking for, and it just throws it right back at you. So a little bit less expensive than noSQL databases. But some noSQL database management systems are not that similar to SQL. Yeah, so here's a side-by-side. noSQL, SQL. This is what we're going to be working with, because obviously this is really confusing right now. And typically you won't see it formatted like that. You'll see it formatted in a way where you're familiar with, like with JSON, so it just like keeps indenting as there's more and more information input into the noSQL database. But if you were to like minify it, that's essentially what it would end up looking like. And that's the end of the differences between SQL and noSQL, because I know we've talked about that a little bit. So now we're going to be talking about schema and query design. So we're going to be exploring different kinds of relationships between data, acquiring language that describes those relationships, understanding how to structure a database in a reasonable and efficient way, and discover how to build SQL queries to find related information in the database. So a schema is the description of the way the data is organized in a database and the relationships among its entities. You can think of it as a blueprint for your database. So it's the overarching container for all of your tables, essentially. And so some of you may be familiar with this. We kind of had a similar exercise on this one. Here we're going to say, pretend we're building a database for a school. We want to keep track of things like teachers, classes, and students. And this is obviously a sample of what that would look like. So these are entities inside of our schema. And before we go any further, we're going to review some terminology. Entities are distinct units of information. In this example, we have 3 entities: teachers, classes, and students. Entities manifest as tables in our database. So we're probably not going to be calling these entities. If you said that they're entities, you probably get what you're saying, but more often than not, we refer to them as tables because it's just a universal understanding that you're immediately talking about SQL and it helps with just, not having to explain what you're talking about if somebody doesn't understand what an entity is. And so these are the fields inside of our tables. Each entity contains one or more fields that describe the properties of the entity. For example, teachers include the fields name, department, and classes. That would be more like it includes the column names, name, department, and classes. And the entry stored in a table will contain the corresponding fields. So entries stored in a table are called records, also known as rows. A row in the teacher table may tell us about one teacher named Cynthia from the music department who teaches music theory and brass method classes. Can you describe the relationships that would exist between these three tables? Does anybody have any ideas what kind of relationships we're going to be building? You guys know what I'm talking about when I'm talking about relationships between? No? So there's three different types. Yes. So yeah, one-to-one. This is pretty uncommon. I have an example pulled aside for you guys so you can just get a visual idea of what that would look like. And of course we have a one-to-many. And finally a many-to-many. So what kind of relationship would students have with classes? One-to-many? Yes.
There's one student and they can have many classes.
Exactly. Yep. I like that answer. We'll continue on. I'm going to try and figure out what's going on here. The slide deck will explain everything. So first we're going to start with teachers. So obviously this is a one-to-many database relationship. It's signified here, this is the one, the infinite sign is the many. We can have one teacher that is teaching many classes. You can kind of think of it in that way. So when you're setting up your database, this is kind of like the way you need to think about setting it up, where are the relationships? This relationship is described as a one-to-many, one teacher to many classes, and how might we define this relationship in our schema? Since we're exploring the classes to students relationship later, let's just omit that for now. And so here's a breakdown of what both of the tables would look like side by side. And in addition to our specific fields, each entity will also include an ID field. And what information should I store to relate teachers? These one teachers to the many classes. Yes, exactly. So here, we're going to, not associated with the ID, but that's the correct answer that I was looking for. Here, it's showing us a problem that we might run into where we would try to associate these teachers with the strings of the classes. The problem with this is that it can keep going on and on and on, and we need a connection between a class and a teacher's list of classes and its corresponding record in the classes table. So this approach creates some extra work to create that extra connection, and it can kind of get cumbersome by trying to figure out exactly which teachers have which classes. It might get very ambiguous if you had 30 teachers, you're working at a university, and all of those teachers have a ton of different classes. That would obviously get very cumbersome and hard to understand. So yes, we're going to be using the unique ID field. Generally, when you're creating a table, you'll hear this referenced as a foreign key, which just means it's a chronological integer that as you put entries in the table, it's going to just keep iterating one up. So as you can see here, this is a foreign key. So we have one entry, and our first entry, this foreign key is 1. Foreign key 2, foreign key 3, so on and so forth. That's the unique identifier because there will never ever be another ID with that exact same integer value as it's stored in an SQL table. Huh?
Even if you delete it?
If you delete that index, if you have it set up correctly so that this column is based on foreign keys, if you delete number 2, this would become number 2, and then if you entered one in, then the new one would become number 3. Well, it does get reused in the sense that you're repurposing it, but it's not necessarily referencing two different data types. You're removing the data it was originally referencing, and now you're inputting a different set of data inside of that unique key. So we can store comma separated class IDs with our teachers. When we reference a table's primary key in a different table, we call that a foreign key. In this example, a class ID is a foreign key that uniquely identifies specific records in the class's table. So we could see Morgan is a psych teacher and he has 6 and 7. So down there we have psych 101 and psych 201. So we give the psych teacher the class ID of 6 and 7, and so on and so forth. So we've addressed the problem of linking records to each other with foreign keys, but we still need to think carefully about how we're building our schema. So once again, we're kind of running into the problem that I mentioned before, where this could be a very cumbersome way to look up a bunch of different teachers with a bunch of different classes. If you had, 30 teachers all teaching different things, it becomes very hard to look this up. So we can increase the column size by allowing for more inputs inside of that column. Comes with some overhead though, so there will be a considerable delay between the user reports and, pardon me, there will be a considerable delay between when the user reports that your tables are no longer working and when you're able to actually ship a fix to it. So don't do this. Frowned upon. Storing multiple values in one column means we lose our constant time retrieval as well, because now instead of being able to just specifically go to one column and one row, now we have to go to the one column and the one row, and then depending on the length of the data inside of that one row, you will have to map through that and try to figure out if it has the values that you're looking for. So this is not really that ideal either. Since we can't store multiple values inside one column, we could try creating multiple records for each teacher, one for each class they teach. Once again, we're running into a problem where we're entering unique keys for the same person in the same department, where we're just associating that one key and changing it at the end. So obviously this once again runs into the problem of if you have multiple teachers with multiple different majors or departments and you're trying to keep track of everything that they're teaching, you would have to go through and try to select, okay, where is Sebastian? Sebastian's here. Okay, what is he teaching? He's teaching this. Okay, but is Sebastian still in here? Oh, he is. Okay, so he's also teaching CS too. And then it would have to go back through again to see, okay, are there any other Sebastians? It makes it, again, a lot more cumbersome. So do not do this. We no longer have a single source of truth. So that's what I was talking about, where this would be a single source of truth if this wasn't here. But since we now have two different rows essentially referencing the same teacher, we no longer have like one teacher. We have to look up multiple teachers in order to find what the teacher is actually teaching. And if a teacher changes their name, for some reason, we have to remember to update every single one of the records as well. So we're not going to do that. For this relationship, the best approach is to store teacher IDs in the classes table. We still have the ability to find all the classes a teacher teaches, and we avoid the problems that we explored earlier. So by adding this extra column in classes, now we know that classes is always going to have all the total possible classes within like a university or a school. And then all we have to do is have a column that's associated with the teacher ID. And so now over here, we just have this very simplified list of teachers with their unique foreign keys, their names and their department. But then when we're actually looking at the classes, we can see that we can have the full list of classes and have it so that we could still specifically look up those classes. And if we wanted to join the tables, we could just use the unique teacher ID to join the tables and find out what Morgan is specifically teaching or what Sebastian is specifically teaching.
So let's just say like Sebastian got fired.
Mm-hmm.
You said that Kelly would now become 2.
Mm-hmm.
So would then Kelly be referencing like 1 and 2 in the classes table, or would, because it has a unique key, would Kelly still be referencing 3, 4, and 5, and 1 and 2 would just no longer be referenced?
That's a good question. I'm pretty sure that if I remember correctly, I apologize. I think I said this wrong earlier. I think Kelly would keep her unique key, but if you entered in data after deleting Sebastian, they would take over that foreign key instead. So I think Kelly would keep the unique 3 key, but then there would be an empty entry in the second one. And so obviously if you tried to join and number 2 wasn't there, then it would say it's not found. But I apologize. 3 does keep its unique key.
So if I hired another teacher and his name was Smith, and he would become 4, and then 2 would just no longer be referenced.
I'm pretty sure, yeah. Yeah.
And then I could go into the teacher's table and then change the 2 to 4 because he's now teaching this class.
And that would be really easy because you could just like use a table join and say select, you know, where teacher ID is equal to 2, and then once you get all of those rows, you can easily just switch it to 4. So we have confirmed this is a one teacher to many classes relationship. Now we're going to touch up on the students. So this is what's called a many-to-many relationship. So the reason it's called a many-to-many relationship is because, if you read the bottom already, we can have many classes and we can have many students attending the many classes. So we have a list of students all attending, you know, a bunch of different classes. So this is a many-to-many relationship. We have many students in many classes. There can be many students per the many classes. So just like in the first example, we'll explore this relationship using data. How can we define this relationship in our schema? Any ideas of how we would be able to associate these 2 tables to one another? It's kind of difficult, right? Especially after talking about what we just did. It'd be hard storing the students specifically here because then we would run into the problem where we're storing the comma delineated values for each student per their unique ID. And then of course the same problem over on classes in the students table. Oh, there you go, yeah. So we know from our prior explanation that we can't store multiple values inside of one column. So storing student IDs in the classes table won't work. If we increase the maximum number of students per class, we'll have problems. So not what we want to do. Well, what about the other side? Storing class IDs in the student table doesn't solve the problem either. How might we accurately show the relationship between entities? We can't store it in the students table, we can't store it in the classes table. I think I heard you say it. Yes, yeah, exactly. So this is just kind of like an overview of what we'd be dealing with. It's a representation of our data in a shaded cell format, and it's showing you like which students are enrolled in which classes. So this is just like a visualization of what we're working with here. So if we swap out the student IDs versus the class IDs, we can plot the intersections of the classes and students using something that resembles a coordinate system. This tells us that class ID 4 contains student ID 3. You won't be looking at anything like this. This isn't what it actually looks like, but this is just kind of like giving you an idea of how we would solve this problem. So now that we are visually able to see the relationships between the class IDs and the student IDs, we can create a new table. So we grab the class ID and we grab the student ID and we associate that with one another. And they don't show it over here, but this join table would have a unique identifier as well over here. So this would also be 1, 2, 3, 4, 5, 6, so on and so forth. And so this would be how we would solve our many-to-many problem, because we would need something that's called a join table. We can't put a bunch of values inside of the one column for classes. We can't put a bunch of values inside of students for all the classes they're attending. So you would create a join table to bring together the many-to-many relationship and make it a lot easier to access the data between the 2 tables. How would you describe the relationship between our classes table and our classes students join table? I'm guessing it's the ID. Any complaints about that, the IDs? We have a one-to-many to the join table and a one-to-many to the join table from students. So although this is showing that it's a one-to-many relationship, essentially this is how we would break down a many-to-many relationship where we no longer have to try and figure out how to store the classes and the students in their own tables. We just have this one singular table for the purpose of making our lives a lot easier, and so that we can access these two tables that are a many-to-many relationship a lot easier. And so this is just kind of like a breakdown of what this would look like all chained together. So we have created a new table now that we know that we have a many-to-many relationship, and then we'll use this classes/students table to join either table depending upon the way that we enter our SQL queries. All right, so we have our schema, now what? Now that we have a clear idea of how entities and their relationships are represented in our database, we can begin to explore how to extract information from the database. And the examples that follow will accomplish this by writing SQL queries against our school database using MySQL. So I am actually not going to go into that because we have not been taught MySQL and it's all done in the terminal. So instead, I'm going to back that out and quickly come over here. This is what a one-to-one relationship would look like, where you would have one person with one passport. So obviously one person's never going to have more than one passport and vice versa. So this is an example of a one-to-one relationship. This is probably not going to show up a lot. I mean, it definitely has its uses, but this is visually what it would look like, where either table between one another has a singular entry that corresponds to one another. So like Joe would have the passport 1, Kelly would have the passport 2, and so on and so forth. So I just wanted to show you guys that. I also had a request to show you guys a good database management visualizer, I guess I could say. So this allows you to essentially get a like how we just had these diagrams up. It allows you to map out before you even start your program, your tables, so that you know exactly how they should be set up before you even start programming. Right now, this is probably not entirely needed for you guys, but as we start building more verbose projects, this is going to be really, really useful, because before you can even start, or before you start, you should try to map it out in a visual way that makes sense to you. So this is completely free. As you see, I just logged in as a guest. We can hit start now. I have a general idea of what's going on. And funnily enough, I do not want to say, we have a very similar example to what we had before. So we can see that the student ID in the teachers is being referenced in students, and then the student ID in student courses is being referenced in students. This is kind of wonky here, but this is just like the template that they load from the get-go. You could easily just come in and delete all these, you know, and just start going on your own. Boom. And so table, add a field, test, type binary, blah, blah, blah. So we have that. Hello. Type binary, maybe we'll do string. We'll allow, Frankie rather. So on and so forth. So before you start your projects with like a huge database that you know is going to have a bunch of relationships, this is great for being able to have a snapshot and image of what it should and what you want it to look like. So I'll write this on the board. I could definitely Slack it out to you guys as well. And once again, it's free. You just have to click login as guest. It doesn't ask for any information. I didn't type in anything before I visited that site. Just go right to that domain and then click login as a guest. And then beyond that, I have just a couple SQL commands that maybe people got confused on. So I'm just going to go over a couple SQL commands past this point. So here we have this giant table with unique keys on the left. Can everybody see this okay? No? Good? Okay. Yeah, no problem. So then we have a supplier ID and we have a category ID. The unit that is actually being purchased by the customer, the units that the product is sold in, and then the price. So if we wanted to select the amount of products that we have in this list, we would use select count and then in parentheses the product ID, which we know is a unique identifier. So we're simply just going to count the amount of products that we're selling, which is 77. So that's how count works, is that it returns the total amount of rows within that column, pardon me. So that's how you would use count if you wanted to find like how many sales there were, or like, you know, how many people are actually in the, you know, so on and so forth. It's pretty basic, but yeah, this is our output from that big table. We got the count of the product IDs.
How would you do show me the name of the salesperson and how many sales?
That would be, well, we were on the product table there. It would probably have to be something along the lines of going to the customers. So here we have the customers and then the orders. We would have to join the orders table on this. So now we can see here we have the customer ID and we would join. So we would say select. You wanted a singular customer? The amount of sales, the amount of orders.
How many each employee sold? How many sales each employee had?
Okay. So we could go select employees. And we're looking for employee number 5. Select employees. Employee ID. Or would it just be yes? Oh, probably didn't want to do that. Select employees, or employee ID is 5. And then we would need to join. Left join the employee. Let's take a look at this table. Employee ID is 5. And we would join pardon me. I think I haven't had a lot of time to look at the complete contents of the table. So we're going to select the orders and employee ID. No. I will come back to you on that. I don't want to waste too much time on this, but I will slack out once I have the actual SQL command. But I have a couple other ones set up too that I wrote before the lecture that I just wanted to show you guys. But that's definitely possible. It's probably going to be a huge SQL command, but it's definitely possible. But I'll come back to that. Unfortunately, I only had like an hour to prep the lecture, so I just wanted to try and get a couple examples of, you know, how these SQL commands work. So wasn't prepared to write SQL off the cuff, but I'll figure it out and I'll get back to you so we're not wasting it, people's time. So with the average statement, what would be going on here is we're just going to be selecting the average price of our products. So over here, we have the price, and as you go down, you can see it's a bunch of different integer values, floats. Really hard to look through and try and figure that out. So with the average SQL command, we can run that, and we can find out that our average price for all of our products is $28 and a bunch of cents. Bunch of really small fractions of pennies. So that's how average would work, is you would select the average price from products, and that would give you back just that one row with the average of the total average of all of your products. Here we have sum. So sum is different than count. I feel like some people kind of get confused between the difference between count and sum. Sum is going to actually add together all of the integer values stored within that row, whereas count is simply going to go through and just give you, like, if you can think of it as looping through an array, count is just going to give you the final index of the last spot of the array, whereas sum is actually going to go through each row and grab that value and then add it all together. So if we're going to get the complete sum of the quantity of products from this order details table, then we would run that command, and now we know that the total amount of quantity of product that we are selling, I'm guessing, because it says order details, I'm guessing that we have 12,743 items in our order details. So that's how sum would work. If we change this to count, it would return something completely different, because it's no longer counting, it's no longer adding together all of the values inside of the row. It's simply just telling me how many rows there are inside of that column. It's air, bud. So this one's a bit different. We're selecting from customers, so I'll pull that one up. So we have a bunch of different customers, obviously. And so what we want to do is we're going to count, not sum, but count. We're going to find out how many customer IDs with country from customers, and then we're going to group this table with country, and then we're going to order the count of the customer ID, and then we're going to have it be descending. So right here, we're grabbing country and we're grabbing customer ID. So that's what this is saying here, is we're grabbing the count of the customer ID, and that's why it's being passed in with these parentheses, is because that's what we want to happen on that column. But country, we don't want to do anything to it. We don't want to count the countries. We literally just want to return like the value at the country. So once we have our select command, we're saying what table we're going to be doing this from, and we're going to group it by country. And now we're going to order it by the count of customer IDs by country. So if I run this, now you can see the count starts at the highest value and then goes all the way down to the smallest values, and then countries are just left non-alphabetically categorized. The way that this happens is because of this descending, I guess, argument, you could say. You could also revert that and have it be ascending. So now we have the smallest count on the left and the countries on the right with the smallest amount of people. And then by default, I think it will return, there we go. By default, it looks like it just saves what I typed in last. Yeah. Typically, you'll want to order it by descending or ascending anyway, but yeah, it seems, at least in this editor online, that if you just send in order by count, it just does it descending, ascending on its own. So this one's a crazy one. So we're going to be selecting shippers, specifically their name. We're going to count the orders on order ID. So that's the unique identifier for the orders. And then as number of orders. So what this means is we're going to be creating a join table essentially, and then we're going to be using orders. So now we're left joining shippers on the orders.shipperID, where it's equal to the shipper ID and the shippers table. So we're joining these two tables together, and we're going to try and find out how many numbers of orders each shipper has. And here you can see we selected the shipper name, we selected the count of orders and their order ID, and then as a number of orders, so this is essentially what the table is named, unfortunately, oh no, sorry, right here, column is named. That's this command right here. This is what allows us to have this column right here, number of orders. We're counting the amount of orders and we're selecting the shipper's names, and then we're going to be returning the shipper's names with the count of the amount of orders that they have inside of that table. And then when you put as, it's just going to rename the column so that way you know that it did actually do the math and execute the way you were anticipating it to.
This is why it's good to be like semantic with your naming of each columns.
Yes.
I was doing the other assignment and there were two contents, and I was like, I don't know which one is from
Yeah.
the posts and which one is from the comments.
Yeah. Something you'll see too is like depending on the table name, so like if you had teachers, students, and classes, you would have the columns named as like class name, student name, you know, just to help you differentiate when you're trying to join them all together. It makes a lot more sense to call like students.studentName rather than like, you know, student.name. I mean, that makes sense obviously, but it just helps, you know, when you're working with a ton of different relational tables to know exactly what the column is referencing. But yeah, typically you'll be calling the columns with dot notation and saying specifically what column you want to operate that count functionality on. And we can also do average as well, or we should be able to. There we go. Orders is a bunch of different numbers, and the same way we can do sum, add them all together, which doesn't make any sense because there's only one order per entry, but essentially we're just adding up all of the numbers together to give us this completely random, not useful column. This left join, essentially what we're doing is we're going to say, let's take the shipper's table and we're going to join it on the orders table depending on the shipper ID, and then as long as it's equal to shippers at shipper ID. So if we go over to orders, we could see that there is a shipper ID right here. So that's how we're able to join the shippers table and the orders table, because we have this shipper ID specified here. So if I go back, that's what we're doing here. Left join always evaluates the first select. So excuse me, that's incorrect. Left join is always going to have it so that that is the table that you want to bring up, and then you're going to be joining another table based upon the values. So this is still the shipper table. If I go to shippers, you could see that it's very basic and rudimentary. So we're left joining on this table because it's so small, and really what we're looking for is the total amount of orders associated with each shipper. And so by left joining on the smaller table, knowing that we have this orders table with associated shipper IDs, by checking it here, we're able to just group it by the shipper name, and we have the shipper name over here, and then we have the number of orders over here. If my memory serves me correctly, if you're doing a join, I do think you need a group by, but I'm not 100% sure on that. But yes, this is how you would use this crazy left join statement where you're looking for the shipper is that shipper name, sum, and blah, 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 blah. We can also do this. No such column shippers. Okay. Do this. There we go. So if you wanted to get every single column and every single row out of shippers, you would do dot notation and just pass in a star, which is kind of like a universal, like grab everything inside of it. And then now we can see, instead of just returning the shipper name and the and just the number of orders, we're able to retain the entirety of shipper. And so now we can see the shipper ID, the shipper name, as well as their phone number, in addition to the count of the orders they have. And so that's how you would have, you know, depending on how many columns you want to bring in, you would be able to specify that up here by using dot notation. Finally, I have this last one. So this is going to be two inner joins, and of course we're grabbing the order IDs off of order, we're grabbing the customer name off of customers, we're grabbing the shipper name off of shippers. And so now we're saying from orders, we want to inner join customers where the order ID for the customer is equal to the customer ID. And then we want to left join the shippers on the orders.shipper ID where the shipper's ID is equal to the ID in ship order. Man, it's dyslexia, sorry. Pardon me. So yeah, I get, you probably get what we're trying to do here. We're grabbing these two tables, we're joining them on where these IDs are equivalent to the IDs in the base table, and then once we run this, we'll be able to see all these three tables combined in a really easy to understand format, depending upon what you were looking for. So, yeah. And of course, joins. We have a little debriefing on that. Nice little chart down here. So when we're doing a left join, like I said, we're retaining the first table, and we're only bringing over from the second table what corresponds to the first table. Where, you know, like we had the order ID, we would be able to say where the customer's order ID is equal to the first table, left join it. And so we're retaining the left table of orders, but now we have the associated customer ID with the actual orders table entirely. An inner join would be when you're just specifically looking for one thing and you're going to be removing data from either, well, not removing, but just like filtering out the data from either side, and you're only going to be returning the exact thing you're looking for. Right join is when you would be passing in two tables, and then you would want to, instead of having it so it joins on the first table, it joins on the second table. And then obviously a full outer join would be when you want to just completely mash together all of the tables for whatever reason. Maybe the tables are very small and it's easy to deal with, but typically you guys are going to be working with like left and right joins. So if you guys ever get stuck, W3 once again is really great for just explaining how all of these SQL commands work. It's really great. Keep in mind that next week we're going to be starting connects, and that's going to kind of take apart having to do all these SQL commands and make it so it's going to be turned into JavaScript. So essentially what you would do is you would type in something like connects table join dot where. Let me pull up so you guys get a good idea. This is what we're going to be working with starting next week. So you could see, oh, pardon me, you cannot see. Oh man, okay, that's probably good enough, right? So yeah, Query Builder, you can use connects to actually make tables and generate tables. It has select, so if we come in here, this is what it would look like. We'd say select the title, author, year from the table books, and then of course it would change the web page. Same thing, connect, select, leave it empty, and then we're just going to enter in the table books, select all from books, so on and so forth. Where, we have a where. Connects.users, so that's the name of our table, and then .where, the first name is equal to test and the last name is equal to user. And then we want to select that ID where that evaluates the truth. So in SQL, this is what it would look like, is select ID from users where the first name is equal to test and the last name is equal to user. This is what we're going to be working with starting on Monday, so I wouldn't be too worried about like memorizing every single SQL command. It's good to know, but it's definitely not explicitly required. And another thing is, I know you can do this in dbeaver. I'm pretty sure, I don't know how to blow this up. Okay, cool. So, I forget how you do it in dbeaver, but I know this is possible as well. But if we wanted to, we could come in here and we could say, yo, teaching And then before we actually enter this in, let's delete this too. You can come down and get an SQL not connected. Ah, I turned off my SQL thing. I can show you guys real quick. Homebrew services. I typed it wrong. It's already started. Pretty much what I'm trying to show you guys right now is the ability to use Postico or dbeaver to explicitly see what is going on under the hood with SQL. Okay, I might need to restart this, unfortunately, but essentially, if you wanted to come in to Postico or dbeaver, you could come in, you could delete this, you could delete that, you could enter in a new one once it loads. Hello, hi. And then when you come down to SQL preview, it would show you how you would do this with an SQL command. So if you're kind of stuck and you're trying to do something with your table and you're not really sure like what the SQL command would be, you could easily go into dbeaver or Postico and just do the actions yourself, and it will give you the SQL command that equates to that action. It's really, really useful. In Postico, you just go into the table, do the actions you want, and then you click SQL preview. I think there's like a window on dbeaver that like as you're doing stuff, it'll just show you like then and there. I don't remember 100%, but I know it's possible in dbeaver. So if you wanted to do something, you weren't sure how, you were looking at the docs, it was very confusing to you, this is another way that you could look up SQL commands to do stuff that you wanted to do. Yeah, kind of a janky example. I don't know why my Postgres is not working, but that is all I got for you guys. Are there any questions about everything I went over? I know I kind of like dumped a bunch of information. It's kind of all over the place a little bit here and there. Have a pretty good grasp on SQL. It's pretty similar almost to like HTML in a sense, where it's like whatever you want to do, there's documentation on it, and you're not required to remember every single SQL command, and then it's very, very it's very easy to understand, very easy to work with. Like I said, you can take apart the actions that you want to do. You can pardon me. You can take apart the actions that you want to do in something like Postico, as well as just going onto the documentation, looking at the examples there. And then, of course, if you want to get, like a little bit of insight of what we're going to be doing next week, we're going to be using connects, and you can look at the documentation on how you would be using SQL commands with connects. It's going to look a little bit different, but the actual keywords like where, join, select are all going to be the same. So if you're having like problems understanding a specific SQL command, maybe look at the documentation and then look at the way that Connects implements it themselves. But Connects makes it a lot easier, and it'll take a lot of the weight off your shoulders. It makes it so that you can generate like dummy tables and dummy information to test against your backend, and then once you're sure that it works, you can just erase it and push it to development, and now you have like a working backend that works because you were able to test it with Connects, and it's deployed, and you know that there's going to be no problems because you were able to generate a bunch of dummy data to fill the tables and make sure that it works. It's really, really useful. We're going to be using it with Express, and once we're at that point, then we'll start working with views, being able to generate different HTML files and all that, depending upon how you want to do it with Connects and your routes. Other than that, just one simple addendum. I think Mitch said he mentioned this to you guys, but we're planning on having a career services lecture on Monday. So we're putting that together right now. Currently, we still don't have a career coach. We're looking for somebody to replace Nick's position. But in the meantime, Mitch and I figured it would be good to help you guys out by just giving you just like some groundwork to help you figure out, you know, like what you need to do or how to excel in, you know, once you're looking for an actual job. Are there any other questions? You good? Awesome. Thanks, guys. I appreciate it.